Welcome to EDU World Space.
We have the following problem. We have this curve in the xy plane. The curve is y is equal to tangent of x. This is
Here's a clean and professionally formatted
y
presentation
equals
of
to
the calculation
tangent
shown in the image.
of x.
Application of the work
we have
energy
that
theorem,
curve
wet. From the
from
work energy
x
theorem,
equals
the
to
force
0
F is given by F equals
up
frac
to
tex KE, where KE equals kinetic energy, S equals stopping
this goes
distance.
away at
I'm given for object A, FA equals frac
infinity at
100,000, 0.10.
by half.
For object
So but
B,
we have
FB
this
equals
one
frac
up to
225, 1500
by
equals
thirds. So
0.15 tech
all this
space n.
continues
And force ratio frac
here. So
FA,
you want to
FB
consider
equals
just
frac
this portion
0.10, 0.15 equal
from
fractional
0 up
result.
to pi
I'm a
thirds,
box frac FA, FB.
and we want to
Would
do
you
the
like a
following.
PDF
First,
version of
this
this
one,
explanation?
I want to rotate about the x-axis, so that we will rotate that piece, this piece from 0 up to pi thirds, up like that. We will get something like that, some sort of like a trumpet, something like that. So we want to compute what is the area of this. So with this the x-axis, and then we'll also like to rotate about the y-axis, so that we have that curve here is the y-axis. This is our nice, wonderful curve, and we want to rotate all there. So we're gonna obtain like a bowl, something like that. We rotate. So we want to compute the area of these two surfaces. So for this one, we know that by the formula, odds is gonna be the integral from 0 up to pi thirds, 0 up to pi thirds of f of x is well, the length of the curve, just dx. So the length of this curve would be square root of 1 plus f prime squared, and well, that times 2 pi. So that is the formula, and well, for this rotation about the x-axis, and also this is, that would be y, this part here is y, and then if we rotate about the x-axis, well, what changes here is that here we have the integral from 0 to 2 pi, from 0 to pi thirds of, well, 2 pi times what appears here is would be just x times x dx. So for this function, for f of x being equal to tangent of x. So if you have if this is our f of x, f prime is equal to secant square. The derivative of tangent is secant, so that so that over this integral, let's call this one I, so that I is gonna be equal to 2 pi is 2 pi times the integral from 0 up to pi thirds of our function tangent of x times s. So this would be square root of 1 plus this square, so secant squared would give us secant to the fourth, secant square of x that square is equal to secant to the fourth power. So we have secant to the fourth, secant of x to the fourth is dx. So that is our first one, rotating about x, and then if we rotate about y, we will have this, so that it is equal to the second one will be 2 pi times the integral from 0 to pi thirds of x times square root of all the same 1 plus secant the fourth power, secant of x to the fourth power dx, and then when we approximate that with our favorite calculator, this is 10.5017, and this is 7.9353. So those are the two approximations to these areas of revolution, like that, like that.